Hello everyone, my name is Anne and today I'm going to be discussing the digitalization of organic synthesis. A quick overview. Usually when we go into the organic chemistry lab, we conduct or we propose different methods or a hypothesis in order to synthesize a certain compound. And in order to support this hypothesis that we've created, it's important to conduct an experiment in the lab to yield the desired product through a set of reactions or reagents. However, creating this compound can have a lot of limits to it, especially when the compound can become complex. It can cause the synthesizing process to be very lengthy and difficult, which is why it's important to rely on the digitalization of organic synthesis. And really, it's exactly like it sounds. It's organic synthesis, but using like a machine learning tool. So if you look in the image here, there's a target molecule, and the computer or the machine computates a certain set of reactions or reagents or conditions in order to synthesize the compound that we are trying to isolate. With this field, though, there are a lot of flaws still and many improvements that are necessary for it to become accurate, simply put. But the most important flaw that needs to be addressed is that there is not a universally accepted synthetic sequence to catalyze a molecule efficiently. So there's not like one spoken language on how a computer is to computate a set of reactions to isolate a product that's spoken among like all chemists. So the goal for this is to achieve a less flawed digitalization of organic synthesis so that it can be applied to other fields such as the medicine or process chemistry field to make those fields a more evidence-led practice. So let's use an analogy, and I've used baking, which is has become very simple to understand, which is, let's say we want to bake a cake. A cake would be analogous to a target molecule that we're trying to create. When baking a cake, a lot of ingredients and a lot of specifics in the recipe go into the baking, such as what kind of pan should we use, how much of each ingredient should be used, what brand is best, what temperature should it be baked at. But it's not that simple, baking a cake. There are so many different ways to bake a cake, and it can be dry, it can be moist, you just don't know, and it depends on the recipe. And this is what the molecule is like. The computer just doesn't know enough to synthesize that compound because there are so many ways that so many different chemists do it, and we just don't know its accuracy, which is why it's important for chemists to develop a universally accepted way to create data sets in order for the computer or the machine to synthesize a compound. A main challenge to this is basically it's messy. Computing this can be messy because the molecules can get too complex. For an example, this compound right here takes about 16 steps or 11 steps, in between step 7 and 8 alone is 16 above the arrow conditions, which means there are 16 like different different conditions that go into just that one step. This shows how complex a molecule could be, and it's one of the most complex molecules to synthesize digitally. So there are just way too many factors to prevent that accuracy, and some of these factors may be what reaction steps are needed, how much time is allotted, is the process to create this time efficient, are there enough materials available to make this molecule, like there's a lot of other challenges as well combined that could lead to failure. And many scientists as well fail to document their mistakes and failures, which could lead to other chemists making that same mistake when trying to compute a molecule. To overcome this, improvements are needed while predicting reaction conditions for machine to use metrics such as efficiency, quality, and yield optimize a synthetic sequence to synthesize a product. There's a tool called CASP, which can produce a product with detailed reaction schemes, but it's limited to more complex molecules. So there are machines such as CAPS who are trying to reach our goal of attaining more accuracy in producing complex molecules. Again, there's no clear criteria for a universal method for efficient synthetic synthesis. And that's our overall problem. Like, there's not one spoken language among scientists. So what steps can we take to improve this messy situation of synthesizing organic compounds? A lot of scientists are creating tools to address gaps in data, such as scientists at Merck are creating tools to reach more efficient communication by incorporating mass spectroscopy to classify structures. Also, the development of Chematica, which is essentially an organic chemistry search engine, is acknowledged for its success in predicting synthesis. So it's a very good step in moving forward in achieving accuracy. Even though it's still flawed, it offers a lot of hope in this field for a lot of chemists. Ultimately, the most important thing to achieve the potential of digitalization of organic synthesis is the collaboration of scientists in developing machine-readable data sets, like in order for it to produce the most efficient method to synthesize an organic molecule.